Hello everyone, welcome to statistics. So today's session will be moving towards to the concept of your skewness. Basically the skewness is nothing but whenever we use this particular skewness concept in the things where we used in a statistic, so we are taking it the things where we are using this to measure the particulars distribution. So basically we use this particular things to the measurement concept. So you can take as in a simple way, if you want to do some measurement on the particulars, we use this skewness concept. We call it this is as a value can be positive or negative. Always it will be taking either positive either negative. It will be taken positive or it will be taken a negative values on that. So that is what a skewness is due for. You can take as whenever you will use this positive skew, it indicates the tail in the right side and the distributed which extend towards a positive value. So in a simple words, you can take as whenever you need a positive value, that time we'll use a positive skewness. Whenever you need a negative value, so we call as it indicates the tail of the left side. So this is positive, or you can take as a right side, we use a positive skewness. Opposite of positive skewness will be using a negative. Negative means it will be taken as your negative values. It takes a negative values and it's a left side. So whenever you need a left side, it will be taking a next left side on that. A value of 0 indicates that no skewness. So we know that this is suppose a number line. Okay, so in a mathematics we learn the number line always. So this will be your 0 on that, and it's 1 2 3 4 5, and when it comes to this side it will be your -1. It means your left side, your right side will be your positive value, your left side will be your negative value. So -2 -3 -4 and continue. The same way in a positive it will be continue. So this side means your this side we call as positive skewness. We call as positive skewness, and this side we call as negative skewness. So negative skewness. So let's move to understand like whenever we having this particular things like positive skewness or negative skewness, there is a one part we call as a 0, right? So what exactly that? So just taking once again the number line. Okay, so it will be a 0 the first one, then your 1, you have 2, you have 3. Same way we are taking the left side -1, then -2 -3. So we know that this side we call as a positive skewness. We know that this side we call as a negative, but the 0, what happened to the 0 then? So just remember that whenever the value 0 indicates, that time the skewness is distributed with the nothing, like perfectly symmetry. A value with 0 has no skewness. So whenever you got this particular thing, it means that no skewness. So that is called as your no skewness, or the particular things where we don't have any values on that. So this is the particularly we use in a skewness whenever we used it. Now to calculate the sample of skewness, or you calculate the data of skewness, we use a keyword called SKEW. You can observe here we take a particular example on that. So it's just a syntax. It's just a syntax wherever we need it. We need a skew number of array values, like whatever the values you wanted, you have to take that particular values here, then it indicates the false and true, because we need to go with that bias which particular thing, true or positive or negative. That values you have to give here to find out the skewness. So this is how we are using this particular skewness to find out the particular things on that. For that you can import your statistic particular things, and then you are moving to using this particular. So we need a data, and just we moving to the skew of that particular data to calculate the skewness. So if you take as a normal way and a simple way, so skewness is a measure of asymmetry of a distribution. So remember that whenever you need to measure a asymmetry distribution, we call as skewness, and this value can be positive, can be negative, this way, this two way. And the syntax of skewness is it's skew and then number of array values and then bias false. False true, that's repeatable because it's positive negative both. So with this I hope you're clear with the theoretical concept of a skewness. Let's move to understand if you import it, how you have to calculate the skewness directly in a Jupyter notebook. So let's move to Jupyter notebook now. So we start to take our values of n, because we need to create that, take in that, because that will be the data of us. So just go with the n equals to, we are taking some values, I'm just taking random values, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 values I'm taking, or not 0, it's 10. So I'm taking some positive values and just run it to take the particulars data on that. So we created that. Now let's move to whenever you have particulars values, how you have to create the skew on that. It takes little bit time to run this. When it's created properly, we can move to the skew part where we can calculate the sample of skewness. So how you have to calculate, just go with SKEW skew, and then we are moving to going with the n, which one we created that, and then the bias, BIAS, bias equals to false. We need to pass that. So this is what a syntax basically is used for. So you can run this particular syntax on that. So this is how you need to use it. It's taking time to run this particular way, and then it's moving to the this way. So this is how we'll be working on skewness and how we'll be running on the skewness. I hope you're clear with this. Whenever we run this particular skewness, it comes give the answers on the skewness of particulars, the variable values, whatever we take in it. So you can observe it's run properly, 1 2 3 5, it's run done. So it's run. Now it's taken time here to run this particulars area. So it will be taking time to give you the output to run this. Yeah, so it's just going with the values wherever we need it, and then it's going with the skewness on that particular thing. Skew and comma bias equals to false. So here what happened, the syntax is nothing, just use the keyword of skews, then moving to the n, whatever the data sets you created, and then go with the bias of the false. So by the help of this, you can calculate the sample of skewness, which means that you can calculate the asymmetric distribution either in a positive way, either in a negative way. So I hope you are clear with this thing.